Good morning. Welcome to the Mind of STEM channel, where you get your daily dose of science, technology, engineering, and math. My name is Leon Jones, and in this segment, I'm going to talk about construction materials. Why? Number one, it's a very interesting subject. And number two, construction materials are very important when it comes to building a project and designing a project as well. So the title of this morning's video is Construction Materials and Their Uses. I'm going to go ahead and share my screen as I talk about it. We're dealing with construction materials. Now, when it comes to construction materials, there are different types of construction materials. Now, what I'm going to do in this lesson is identify a variety of basic materials that are used in construction, identify basic components of concrete, describe different types of masonry, brick, block, and mortar, and classify wood as either hardwood or softwood. Also, we'll recognize different structural steel shapes, describe various types of glass, plastics, and insulation, identify symbols representing materials on a drawing, and explain the fundamentals of green building construction. Now, first, I'm going to get into aggregates or earthwork. Now, when you see the division 31, that's part of the CSI specs. CSI stands for Construction Specifications Institution. Now, I'm going to say 2014 and previously, there were 16 divisions of CSI specifications. Now, they're 51 or 50, correction, they're 50 divisions. And each division is a category, like earthwork. Now, under earthwork, you have your aggregates, also referred to as gravel, used in many construction applications. And the good thing about gravel, it's good for sub-base support, foundation backfill. You can utilize it for underground drainage, and it's fantastic material, depending on what type of aggregate you're using. When you place pipe, you also place fill around pipes, compact it, and then you actually place soil on top of the pipe. Sometimes you utilize filter cloth as well. And also, when it comes to aggregates, they're great ingredients inside of concrete. Now, types of aggregates. You have your pea gravel. Your pea gravel is small rounded pieces, 1/4 inch to 3/8 inches in diameter. River gravel, which is basically large aggregates dredged from river bottoms. And of course, your crushed stone, like your riprap, your 57 stone. It's mined stone mechanically fractured to size. In other words, they take a big boulder and they run it through a crusher. Now, different aggregate symbols. Now, as you see this first symbol, you have your head wall. Then you have your riprap. Your riprap is your great big stone. See riprap under certain bridges. And also see riprap around bridge supports to keep the scouring from occurring. Scouring is basically erosion. Then you have your sand. Sand is a good absorbent material. A lot of your buildings on beaches are built on sand. You have your pea gravel. This is a symbol for crushed stone. Of course, your gravel driveway. Very important that you understand these symbols, because when you go to read plans, you're going to need to know where your materials are going to be placed. Then you have your division 3, concrete, which was used by the Romans as early as 100 BC. Within concrete, it's a mixture of cement, sand, aggregates, and water. And then hardening is caused by hydration, which is a chemical reaction between cement and water. Most mixtures set in 4 to 12 hours, and concrete is generally held in place by forms. Now, when it comes to the hydration process, it's affected by temperature. Reaction slows when the temperature is below 70 degrees Fahrenheit, and reaction completely stops around 32 degrees Fahrenheit. Why? Because at 32 degrees Fahrenheit and 0 degrees Celsius, that's when everything freezes. Now, too much water reduces the strength of concrete. That's why we have a WC, which is a water to cement ratio. And that's basically determined by construction requirements, because most concrete design strengths are reached within 28 days of placing concrete. And then forms are removed after concrete sets. Now, when it comes to green building, you hear the term fly ash. Now, fly ash is basically produced when coal is burned to generate electricity. Fly ash is used in concrete. It's good for numerous environmental benefits, and it creates a more durable final product. Now, when it comes to cement, there are 5 basic types of cement. They include type 1, which is normal. Type 2 is moderate sulfate resistance. Type 3 is high early strength. This is what's basically used on roads. Then you have type 4, which is low heat of hydration, and type 5, which is high sulfate resistance. Type 1, which is Portland cement, is the most commonly used, because you can have that at 3,000 psi, 4,000 psi. Psi is pounds per square inch. Now, when we deal with concrete, the measurement is always in a cubic yard. Now, if you get a sheet or ticket from a driver, you're going to see a few things on that ticket. Well, in this 1 cubic yard of concrete, you generally have 10% cement. Fine aggregates, which is your sand, is 25%. Coarse aggregates, when something is coarse, it has voids in it. In other words, I could pour water through coarse material and it would go right through coarse material. But when something is fine, the particles are very small. Okay, now you have air entrainment, 1 to 5%, and water is 15%. That's what makes up your concrete mixture proportions. Now, your admixtures include air entrainment, retarders, accelerators, water reducers, and coloring agents. Now, when we talk about coloring agents, that's when you have that decorative concrete. Reinforced concrete. Well, one thing about concrete is that it has great compressive strength, but you need some tension, because the tension is poor. That's when you use what we call rebar, which is reinforcing steel, and that overcomes the weak tensile strength. Also, you have the deformations in steel bars, strengthening bonding with concrete, and bars are also set in place prior to placing concrete. Again, here's what you would see as an example when we talk about reinforced concrete. You see the bars. You have these J bars, which are hook bars. You also have, these are very big bars. They could be number 6, number 8 bars, but you need those bars in place. Now you have these column bars as well. These bars provide the tensioning for reinforced concrete. Now, again, let's talk about reinforcing steel because I just mentioned something called a number 8 bar. Okay, now, when we talk about reinforcing steel, we deal with what we call a bar number. And a bar number is converted by multiplying 1/8 of an inch to find out the actual bar size. So when I mentioned a number 8 bar, and if I multiply a number 8 bar by 1/8, then that means I have a bar that is 1 inch in diameter. And in construction, you're going to hear the terms number 3, which is 3/8 of an inch, number 4, which is a half inch, number 5, because that number is what's over 8. That's where you get the 5/8 of an inch and the 1 1/4 inch. And here in my lesson, you can see the different types of bars. Now, you have welded fire fabric, and that's basically prefabricated material used to reinforce concrete slabs and floors. It consists of a mesh of wires welded together. Smooth welded wire fabric equals W. Deformed welded wire fabric equals D. Again, deformed welded wire fabric equals D. Now, why am I saying this? Because you're going to see a lot of these symbols on plans and you need to know how to read your plans. Okay, when we deal with welded fire fabric, it's basically material that's designated by numbers, like we say 6x6, which is W 1.4 by W 1.4. Well, what that is the first 6 means longitudinal wire spacing. The second 6 means transverse wire spacing. Now, when I talk about longitudinal, that's vertical. Transverse is crosswise. Now, when I talk about the W again, that means your wire is smooth, and your first 1.4 indicates your longitudinal wire size, and your second 1.4 indicates your transverse wire size. So that means you have wire spacing 6, transverse spacing 6. It's smooth wire, and it's longitudinal 1.4 by transversal size, which is 1.4. And here's a look at what you would see with welded fire fabric. Well, we used to call it wire mesh. And here are the common stocks of welded wire fabric. Okay, from concrete, we go into masonry. Masonry is where your bricks, your CMUs, your stone and clay tile, they are. And of course, building units with many applications in construction. Again, just told you, we deal with brick, CMU, which is cinder block or concrete masonry unit, clay tile, and stone. Now we have types of brick, adobe. You know, the Africans used a lot of adobe brick. They made everything with mud. There's kilburn, sand lime, concrete, building, faced, glazed, fire brick, and of course, brick pavers. Brick pavers are those bricks that are decorative. Then you have brick positioning, your stretcher, your header, your sailor, your row-like stretcher, row lock, or your row lock stretcher, correction, your soldier brick. And you look at the information that I'm providing you, you can see how your bricks are placed. Bricks are generally, for the most part, the ones that we see with your face brick, they're basically placed in courses. And you have your types of masonry walls. You have your single width, your composite, your cavity, and your veneer. Stone masonry. Common materials are granite, limestone, marble, sandstone, slate, cut stones, and your cut stones are removed from your quarry. Stone masonry, where you have your rubble. And of course, rubble is stones laid in a irregular pattern with varying shapes and sizes. Your ashlar bricks, or your ashen stone, which are squared stones laid in a pattern but not cut to dimensions. And you have cut stones, cut at a mill to dimensions and laid according to design. And again, when you're looking on your plans, and even computer-aided drafting has them in their hatch patterns, you can see the types of stone masonry walls. Then you have your structural clay tiles, similar to brick, but a larger unit of rectangular open cells, has many construction uses, such as load-bearing walls, backup for curtain walls, fireproofing around structural steel. And one of my favorites, mortar. Mortar is a good adhesive to actually cement brick together. You have your type M, your high compressive strength with good durability. Type S, high strength with a stronger bond. Type N, general use with a medium strength. Type O, low strength for use in interior non-bearing masonry. Type K has very low strength and should only be used for interior applications. Now, you're seeing a lot of letters, a lot of nomenclature, because they come up with all of these individual symbols by testing the material. It's very important that you know this, because your specifications are going to have all this nomenclature listed. Okay, then you look at your masonry material symbols. Okay, we get into metals, used extensively in construction, because you have metal studs, beams, and joists. You have windows and doors. Of course, metals used for roofing, plumbing, and hardware. Kinds of metals, your ferrous metals that contain iron as a principal element, usually have magnetic properties, and the ferrous metals are basically iron and steel. Now, when we deal with non-ferrous metals, that means the metals don't have any iron, no magnetic properties. They're lighter and less strong than ferrous metals. And these metals can be brittle. Aluminum, copper, brass, and bronze. Again, these metals are aluminum, copper, brass, and bronze. Surface treatments, because you want to keep everything from rusting. You have chroming. Chroming applied as a finish to a metal surface. Galvanizing. Now, galvanizing is used on rebar as well, just like epoxy. Now, galvanizing is coating of zinc on iron or steel to resist rusting. And you have rusting. It's a protective layer of rust formed on certain steels. Electroplating, adherent metallic coating applied by means of an electric current. Again, metal gauges. Metals less than 1/4 inch in thickness are classified by a gauge system, and you can see it right here. Structural steel. It's a term applied to hot rolled steel sections, shapes, and plates. Structural steel designations. When you have a wide flange beam is what we call a W beam, W12 by 16, which indicates 12 inches deep, and the beam weighs 16 pounds per linear foot. And then you have your angle, which is your L. L3 by 3 by 1/2 indicates that both legs are 3 inches long by 1/2 inch thick. And you can see here in this presentation some of your structural steel designations. Again, all this is going to be on plans, and it's good that designers, particularly structural engineers, architects, know this nomenclature. Again, here are more structural steel designations. Then we get into division 06, wood, plastics, and composites. Now, wood has high strength and compression and tension. It's also used in structural framing, rough carpentry, and trim, floors, walls, and cabinetry, or finished cabinetry, classified as either hardwood or softwood. Again, types of woods. Have them right here, your ash white, beech, birch, cherry, elm, gum, hickory, mahogany, maple, oak, walnut. Those are your hardwoods. Your softwoods, cypress, Douglas fir, white fir, hemlock, ponderosa pine, southern pine, white pine, yellow poplar, eastern red cedar, western red cedar, redwood, spruce. And if you're familiar with those names, wood comes from trees. And you have lumber, classified as rough sawn or surface to size. Now, rough sawn lumber is cut to size, but not dressed or surface, whereas surface is finished to size by running it through a planer. S2S means finished on two sides, while S4S means finished on four sides. And you got plywood made of several layers. Grain is positioned at right angles from layer to layer, and you have odd number of layers used, grain of the face and back run in the same direction. Panels are finished in thickness from 1/8 inch to over 1 inch. Your glue laminated timber, made of layers of lumber bonded with adhesives, used to fabricate a member of any size, including wood beams and arches. It's basically prefabricated at a factory. Then we get into division 09, finishes. Visible surfaces of a building, like your carpeting, your gypsum wallboard, ceramic tile, and paint, specifically designed on the room finish schedule and specifications. Gypsum wallboard and plaster, which is made of a core of entrained or air entrained gypsum. Again, gypsum wallboard and plaster is made of a core air entrained gypsum between two layers of treated paper. Typical sizes 4 feet by 8 feet sheets. Custom sizes can be ordered in quantity. Ceramic tile is used on floors and walls. It's glazed or unglazed. Then you have your mosaic tiles. Now, when it comes to mosaic tiles, it's used to make designs and patterns. Then you have quarry tile, which is wear resistance. Quarry tile. Quarry tile is wear resistant. Whereas again, going back to mosaic tiles, it's used to make designs and patterns. Then you have your fire clay tile, used for floor coverings. Tile setting materials. Ceramic tile is set in Portland cement, latex, adhesive, epoxy mortar, and joints between tiles. You have a lot of mortar that grouts the joints between tiles. These are what your plans look like. And you should understand how to read plans, because all your materials are going to be right on your plans, and you're going to have your general notes to tell you this information as well. Then we get into glass. It's ceramic material formed at temperatures above 2,300 degrees Fahrenheit, made from sand or silica, soda, sodium oxide, and lime, calcium oxide. Of course, adding other chemicals change the characteristics of glass. Float glass, the most common type of glass. A continuous ribbon of molten glass flows out of a furnace and floats on a bath of molten tin. When it comes to irregular shapes, they're melted out. Glass is fire polished and annealed. And over 90% of the world's flat glass is float glass. Types of glass: you have heated, annealed glass pressed over a form. Safety glass, which is tempered, laminated, or wired. Insulating glass, patterned glass, stained glass, also called art or cathedral glass. And when we talk about cathedral glass, you look at some of your big cathedrals, your churches, like St. Patrick's Cathedral in New York. And you can see the stained glass over in Italy, in the Vatican. Beautiful architecture. Okay, we get into what we call green building. Green buildings feature high efficiency windows, which are high efficiency, triple glazed for cold climates. They reduce heat loss by 15% to 30%. Then you have your double glazed for warm climates, fills weather needs, meets code specifications. Here's a picture of your window with insulating glass. Plastics used in many construction applications, your countertops, your door veneers, wall surfacing, gutters, and pipes. Insulation used to reduce heat transmission. R value includes resistance of heat transfer, classified as flexible, loose fill, reflective, rigid, which is structural, and non-structural. Of course, here are your symbols. And when we deal with green building, describes construction methods used to build more efficient structures. Should say more environmentally friendly or energy efficient structures, because the benefits of green building are very simple. They're to protect the ecosystem, improve air and water quality, reduce material waste, and reduce building operating costs, because it does cost a lot to run a building. Green building starts with site selection. So you have to remove as few trees as possible. You have to control erosion, control water runoff. Pervious concrete used to reduce water runoff. Landscaping plants selected based on local climate. It's an example of what we call a green building. Look at the vegetation on the roof. It's very energy efficient. In fact, when you go into these places like Walmart or even Aldi, used to have the drop ceilings. You don't see the drop ceilings anymore. You can actually see they look like truss, your joist. Well, let more sunlight in to make the building more energy efficient. Again, green building, it's good for energy efficiency. So you have to analyze the shape of building and orientation to sun to help reduce cost. Use well-sealed windows with low thermal transmission. You also have interior windows to help save lighting costs. And efficient lighting systems use sensors to switch off unneeded light. That's when you can leave a building and your lights go off. That's what they're talking about. Again, material selection. Recycled or renewable materials help conserve resources. So you have to avoid materials that emit volatile organic compounds known as VOCs. And you have sustainable materials that maintain long-term building performance, engineered lumber and steel. And when we deal with green building, just explain VOCs, volatile organic compounds. Well, what happens is toxic substances evaporate into the atmosphere. And what happens when that occurs? Well, you have your harm to environmental and health, which you get headaches, nausea, organ damage, and even cancer. So when we talk about materials, you want good green materials, a good green building, got to do some research. Look for organic alternatives. And again, when we talk about materials, materials are very important. You must select the right material for your building. And it's very important that designers and construction personnel understand materials. Materials are also tested. So when it comes to materials, got to identify a variety of materials used in construction. Got to identify components of concrete, mortar, brick, block. And you have to understand that wood is classified as hardwood or softwood. And when we deal with steel, there are different shapes of steel. There are different types of glass, plastics, and installations. And you need to understand what green building construction is. And when it comes to plans, you need to know how to identify symbols that represent materials on drawings. And that concludes this topic on construction materials and their uses. If you like what I just presented, please comment, share, and subscribe. And if you're looking for some hard-hitting political and social content, check me out on the 401 Talk Zone radio show on Blog Talk Radio, and of course, YouTube. And if you can't find me on YouTube or Blog Talk Radio, you can simply look me up on Twitter. And once again, thank you for viewing this information on construction materials and their uses from the Mind of STEM channel. Get your daily dose: science, technology, engineering, and math. Till next time, my name is Leon Jones. I wish you all to have a wonderful and gracious day. God bless you.